We are going to solve a heparin problem based on a patient's weight. As we look through the problem, we'll underline some of the key features. First, we see the client's weight is 125 pounds. Second, we see that there is a heparin infusion available as 250,000 units in 250 milliliters of D5W. We recognize this as an IV fluid. Next, we see that there are two different infusions going on. The first is a bolus. We recognize that that would be given with a syringe through the IV tubing as an IV push. And then we see the drip, and we recognize that that would give us the setting for our IV because that has the per hour to it, and so we can convert that to milliliters per hour. I'm going to explain the problem using dimensional analysis. You will also see the pop-ups come and to help you work through the problem using the proportion method or using the nursing formula. To start this problem, we'll need to convert our patient's weight. So our patient weighs 125 pounds, and we'll need that weight in kilograms because both the bolus and the drip are per kilogram. We know that there are 2.2 pounds to 1 kilogram. That will cancel our label of pounds. We'll go to our calculator to do the math. Because this is an adult and because the weight is over 10 kilograms, we'll round this to the nearest tenth, and so we'll give an answer of 56.8 kilograms. The first question that we're actually asked is about the bolus. The information for the bolus is the 80 units per kilogram. We're to convert this to a label of units. So I'll start with the 80 units per kilogram. To cancel the label of kilograms, I'll multiply by the patient's weight of 56.8 kilograms. And that cancels the label of kilograms and gives us an answer in units. On our calculator, we'll take 80 and multiply it by 56.8. Our final answer then is 4,544 units. This comes out to a whole number, so we don't have to do any rounding at all. At this point, we're done with the bolus. Our next question asks us about the IV drip. For the IV drip, we have 18 units per kilogram per hour, and we'll start with that piece of information. Both labels of kilograms and hour belong on the bottom of this fraction. When we look at the answer we're to get units per hour, which means we just need to cancel the label of kilograms. In order to do that, we'll multiply by the patient's weight of 56.8 kilograms. The label of kilograms will cancel. We'll go to our calculator. And we get an answer of 1,022.4 units per hour. This is to the nearest tenth, which is how we typically round for a dosage, and we'll just write this without rounding it at all. The next part of the problem also is talking about the IV drip. This time it asks us to convert the IV drip into milliliters per hour. We're going to use our answer to the previous part as our starting point. In order to convert this to milliliters per hour, we need to use the fluid that will be infusing through the IV bag. We've underlined this information in the problem. There are 250,000 units, and that will go on the bottom of our fraction. The 250 milliliters will go on the top of our fraction. These two numbers must be in the same fraction because they are in the same IV bag. Setting up our problem this way allows us to cancel the label of units, and we see that the remaining labels will be milliliters per hour, which is our goal for this problem. We have our previous answer on our calculator. We'll multiply it by 250 and divide it by 250,000. This gives us an answer of 1.0224. Because it is a milliliter per hour rate, we would typically round this to the nearest tenth. When I look at the tenths position, it is a 0. Within the metric system and the medical field, we do not write trailing zeros, so I give my answer as simply 1 milliliter per hour.